Hey everybody, it's Miss Hall. It is Monday, January 28th, and y'all have a sub today. So thank you, first of all, for being respectful and treating them with the same respect you give me, and for finding your way to this video. First step. Good job. So this is our notes. You should all have a printout of these notes, and we're just going to fill them out together so that we can stay on track for when I get back tomorrow. So first of all, go ahead and put your name right here. I'm going to put my name. That's not your name. Make sure you're putting your name. Okay. First things first. Friday, we were talking about the Pythagorean theorem. So we're just going to write out the definition of the Pythagorean theorem. And we're going to put it in a conditional statement form. So if-then form. So here we go. If a triangle is a right triangle, then the square, like you know how you square something, then the square of the length of the hypotenuse or C is equal to the sum of the squares of the length of the length. Is equal to the sum, adding it up, of the squares of the lengths of the legs. A and B. Okay. And that gives us the Pythagorean theorem equation. A squared plus B squared, those are the squares, the sum of the lengths of the legs squared is equal to the square of the hypotenuse. So now today we're going to be talking about the converse of the Pythagorean theorem. And if you recall back from when we did conditional statements, the converse is where you switch the if and then statements. So see the if statement right here, if, and then the then statement is the rest of it, then blah, blah, blah. So we're just going to switch them, and we're going to write it again. Okay? So now we go, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the two other sides, then the triangle is a right triangle. Now notice it's at the length of the longest side, because before you know that it's a right triangle, you can't call it the hypotenuse. It's just the longest side. And so it's still C. The longest side is still C. And the two other sides are still A and B. So if that is true, then we know it's a right triangle. So that's how it's the converse versus starting off as a right triangle and being able to figure it. And we kind of touched on that yesterday in our warm-up when we were saying, do these three values create a right triangle? Okay, today we're going to go even a little bit more in depth in that we're going to be able to tell, one, if it's a right triangle, two, if it's an obtuse triangle, 3 if it's an acute triangle, and 4 if it doesn't even make a triangle to begin with. Okay? So, we already know that if a squared plus b squared equals c squared, then it is, in fact, a right triangle. Now, the other two things that we're going to be talking about today is if a squared plus b squared is less than c squared, it's an obtuse triangle. Because then it would look something like that. An obtuse triangle where this is greater than 90 degrees. And then lastly, if a squared plus b squared is greater than c squared, then it's an acute triangle. So that's when it would look something like this. All three angles are less than 90 degrees. So we're going to use this newfound knowledge and we're going to figure out if these side lengths that were given, what type of triangle they are. If it's a right triangle, an obtuse triangle, or not a triangle at all. Okay, so this first one, now I've given you this table. We're going to end up figuring out what type of triangle everything is. But step by step, we're first going to square the longest statement. We're going to add the two shorter statements. And this is effectively a squared plus b squared. And this one is c squared. So that's all we're doing. Okay, so go ahead, take a minute, try and do this first one. Take the sum of the squares of the two shorter sides. Go ahead and pause the video and do that now. Okay, so hopefully you pause the video, and then you can see if you add the squares of the two smaller sides, you get 169. And the largest side squared is also 169. So it does, in fact, a squared plus b squared does equal c squared. Therefore, this would be a right triangle. Okay. Okay, so next we're looking at 6, 12, and 15. So go ahead, pause the video. The longest side is 15, so we're going to get 15 squared. And then the two shorter sides, 6 squared plus 12 squared. Go ahead and pause the video and get that right now. Okay, so hopefully you paused the video and you got 15 squared is 225. And then the shorter sides added together is 180. Now if we look at our rules up here, a squared plus b squared is less than c squared. So this is going to be an obtuse triangle. Because a squared plus b squared is less than c squared. 180 is less than 225. Alright, the next one, 5, 12, and 12. So 12 is both one of the legs and the hypotenuse. So then we do 5 squared plus 12 squared. Pause the video, go ahead and get that real quick. As you can see, a squared plus b squared is 169. Therefore, it's greater than c squared, which is 144. So a squared plus b squared is greater than c squared, which makes it an acute triangle. Alright, let's do it again. Try and pause the video. See if you can get all your squares to determine if it's a right, obtuse, or acute triangle. So again, a squared plus b squared is less than c squared. 169 is less than 225. Which makes this an obtuse triangle. So I don't know if you've noticed up to this point, but if you take the two smaller sides, 5 plus 12 is 17. 6 plus 12 is 18. 5 plus 12 is 17. Again, 5 plus 12 is 17. You'll notice that all of those added together are greater than that third side. Because it makes sense. If you're trying to make a triangle, and you have a side that's 20 long, and then your other two sides are maybe 2 inches and like 4 inches. Is there any way to actually make a triangle out of those three sides? No, those two sides will not reach each other. So you got to be careful. I think we talked about this in like Unit 2. you got to be careful. Those two smaller sides have to add up to be greater than, not just equal to, greater than that third side. So on this one, I want you to be careful. 5 plus 6 is what? It's 11. Is there any way for those three side lengths to make a triangle? No. So can this be a triangle? No. Not a triangle. So before you're doing all this, just double check that it actually can be a triangle before you do all this work over here. Okay? So this next one, 6 plus 12 is 18, so we're good to go, and we can actually do it. So go ahead, pause the video, take a second, and figure out these squares. As you can see, a squared plus b squared is greater than c squared. Greater than c squared. So according to our little chart up here, this would be an acute triangle. Okay, and then the last one, remember we always double check, is 6 plus 6 is 12. Is that greater than 12? No. So is this a triangle? No, not a triangle. Easy peasy. Okay. Moving on. Not really moving on. We're just going to do a little bit more practice. So we're going to use the Pythagorean theorem, the converse of the Pythagorean theorem, to determine whether each of the following sets of side lengths form a right triangle. If a right triangle is not possible, tell whether an acute, obtuse triangle or no triangle is possible. So we're just practicing again. So really quickly, before we do any of that math, we got to double check, is it possible to make a triangle? So take the two smallest sides, 12 plus 34 is 46. Is that greater than the other longest side? Yeah. So we can get going. Okay? So we're going to try and figure out a squared plus b squared. Is it equal to, greater than, or less than c squared? Okay, so we're going to fill in basically the sign. So we've got a squared is 12 plus 34 squared. And it's equal to, greater than, or less than 37 squared. Pause the video, figure it out. Turns out that a squared plus b squared is less than c squared. And if you go up to what we learned earlier, less than a squared plus b squared is less than c squared, which makes it obtuse. This is an obtuse triangle. Okay. Number 2. First of all, we need to double check, do these add up to be greater than 10 sevenths? 6 plus 8 is 14 sevenths. Sure does. It's bigger. So now we're going to do, let's change the color, a squared plus b squared is equal to, greater than, or less than c squared. So why don't you go ahead and figure that out right now. Be careful with those fractions. So hopefully y'all were careful and you did not start rounding, because if you start rounding, you will not get the right answer. You're going to have to keep this in fraction form. So if you do this in the calculator, that's fine. You get a decimal and then you push math, enter, and it turns it back into a fraction. And you can see that 100 over 49 is equal to 149. Because if you started rounding, you would not know that this is in fact a right triangle. So please, please, please be careful. And just keep things in fractions. It's much better. Don't round. Don't round, people. Okay, number 3. First, we check, is this greater than 21? Turns out, yeah, it's approximately 26.5, so it is greater than 21, so we can do it. We can do a squared plus b squared is equal to, greater than, or less than c squared. Pause the video, figure it out. So be careful when you're squaring a square root. They just cancel each other out, and you get 42. So you end up with 442 is greater than 441, which makes this an acute triangle. Last one, I want you to try and do this on your own, and then you're done with notes. Double check, can it be a triangle? So hopefully you all saw right away that 12 plus 5 is only 17, and it's not greater than 20, and therefore this is just not a triangle. Okay? So the sub has your homework. That's all you have for today. It's the notes and the homework, and I will see you tomorrow. Thanks so much. Bye, guys.